Hello, 112 students. Based on your mud cards in class today, I thought I'd throw together this quick video on standard cell notation. We're going to talk a bit about what it is, the rules for constructing standard cell notation, and then I'm going to show you 3 examples of different kinds of cells. To begin with, standard cell notation is a shorthand for describing the composition of an electrochemical cell. Its main function is to let us focus on the important redox reaction that's occurring in the cell while ignoring the spectator ions that aren't really participating. The first rule is that the anode is written on the left and the cathode on the right. They are separated by a double vertical line that symbolizes the salt bridge. We only need the symbol because what's actually in the bridge isn't really important to us. Second rule, in the anode or cathode, the reactant species is written on the left and the product species on the right. Phase changes, so this might be going from solid to aqueous or aqueous to gas, are denoted by a single vertical line. Multiple species in the same phase are separated by commas. There's an example that shows you this later on in the video. Lastly, if you know the molarity of any aqueous species, you want to use that in place of the aqueous designator of state. You can leave out the aqueous if you use a molarity because the aqueous part of it is implied. Let's take a look at some examples. The anode of a cell is copper wire in copper 2 nitrate solution, while the cathode is silver wire in silver 1 nitrate solution. Well, the first thing we need to do is identify our half reactions. And the second thing I'm going to notice about this is they don't give us any concentrations, so we're going to use the aqueous designators in our cell notation. Our oxidation half reaction, which is happening at the anode, is copper solid becoming copper 2 plus aqueous. And our reduction half reaction happening at the cathode is silver plus aqueous becoming silver solid. So if we put this all together in our standard cell notation following our rules, we've got copper solid, single divider line, copper 2 plus aqueous, double divider line, Ag plus aqueous, single divider line, Ag solid. Let's take a look at another reaction. Now in this example, we're looking at the copper 2 nitrate versus silver 1 nitrate situation again, but now we've been given molarities for the dissolved salts. This means that we're going to put those into our cell notation. So now, in addition to talking about our oxidation half reaction, we're going to note that the molarity of Cu2 plus is 0.025 molar because you get 1 copper 2 plus for every 1 formula unit of copper 2 nitrate. In the reduction half reaction, we're going to add that the concentration of silver plus is 0.050 molar. We're pulling these straight from the problem description. So we plug these into our standard cell notation, and now it reads copper solid, single divider line, copper 2 plus 0.025 molar, double divider line, Ag plus 0.050 molar, single divider line, Ag solid. And I'm calling your attention to the fact that we have replaced those aqueous designators with their molarities. Let's take a look at one last example. The anode of a cell is the oxidation of zinc metal. The cathode of a cell is dichromate ion being reduced to monoatomic chromium ions. So in this case, our anode is a metal to aqueous sort of transition that we've seen before. But now our cathode is 2 aqueous species reacting. So let's take a look at what our half reactions are. Our oxidation is zinc solid becoming zinc 2 plus aqueous, and our reduction half reaction is dichromate, Cr2O7 2 minus aqueous, becoming chromium 3 plus aqueous. Now you'll note that the second one isn't balanced. That's okay. We don't care about balancing things in standard cell notation. Let's write this out. Our anode looks like zinc solid, single divider line, zinc 2 plus aqueous, double divider line. Now we've got Cr2O7 2 minus aqueous, because this is the reactant in the reduction, comma, Cr3 plus aqueous. So we see that comma, we're not changing phase. We're going aqueous to aqueous. So instead of using a single divider line, we use a comma, as we saw in Rule 2 way at the beginning of this video. So I hope that this provided you with a little more familiarity and a little more knowledge of how to use standard cell notation. With that, I will see you guys in class on Wednesday.